Hi, David Maliniak at CES 2023. I'm not in a car, but I am in the booth of Yank Technologies. Yank is revolutionizing wireless power, and its CEO Josh Yank is going to take us through a quick demo of the technology.
As I turn on the unit, it's going to illuminate blue to indicate that the system is on. Really what we wanted to show today is just some key hotspots that we can create throughout the vehicle, not only for passenger devices, but other kinds of devices as well. So now this phone, for example, is being powered like just through the material. We could also do a second phone over here, for example, just to show some common use case positions. And we could also, for example, show this is just a standard roll top, but we could go through the roll top material in order to power your phone. And also power them in other convenient locations, such as like in the cup holder area. So I can just put it down in there and you're good to go. But we often work with our automotive customers to actually power internal electronics. So things like lights, for example. So you just kind of put the lights into the charging bubble, and then you'd be able to power it wirelessly. So we do power directly actually for not only ambient lighting, but car seat subsystems to remove the wire harness connection between the body of the vehicle to the seat. Similar concept for removable doors. So that way the A or B pillar, you don't have to snake a wire harness connection to the door. Make it more reliable, reduce warranty expenses, and include new features. So that's typically what we do.
Okay, tell us a little bit more about the workings of the technology.
Yeah, sure. So we do resonant induction, which is kind of like cousins to induction, but resonating at a particular frequency. We typically resonate at 6.78 megahertz in ISM band. So what we do that's pretty different is we have very high intrinsic quality antennas. So they could couple very significantly at further distances. So for example, a typically Q factor of inductive charging pads today, resonant that is typically 50 to 100. We could develop antennas above 1,000 for our automotive systems. That alone is not enough though, because the movement of your devices is going to affect the reflections that the amplifier sees. So we also have what we call dynamic impedance matching networks and also new amplifier topologies to handle these wide swings in movement. So that way it doesn't necessarily matter what kind of device it is. It could be a seat moving, it could be a passenger device, it could be a door. We could very readily adjust to that type of application.
Okay. What changes, if any, have to be made to devices to be powered this way?
Very good question. So there is a change for passenger devices. To be clear, we're using phone cases today, but we are collaborating with phone manufacturers, for example, to embed it directly. We would need to resonate at our frequency band of 6.78 megahertz. So it would be something similar to like the Air Fuel Alliance, for example, and their wireless power standard for resonant induction. So it is similar. You would likely need a little bit of a different antenna that would work better at resonance, and you would also need to have tuning capacitors and matching capacitors for that resonant band.
Okay. And are you making efforts to drive this as a standard in the industry at this time?
Yeah, so we are on the board of directors of Air Fuel actually to help guide decision making in the industry moving forward. I definitely see a world where there's different types of wireless power that can be used to solve different types of problems, with resonant induction having really interesting applications for higher powered systems requiring more than several watts, that also require typically within, let's say, 1 meter vertical distance requirements.
All right, very good, Josh. Thank you very much for the overview, and we'll look forward to more from Yank Tech down the line.
Yeah, sounds great. Thanks a lot.